Turn to us. Yes. Where have you been, young lady?
Okay. Page 105. Your book's going to be sideways. Okay. And what we're looking at here is patterns in the periodic table. So we are looking at what does all of group 1 look like. So we're going to first focus on group 1. And I would like you to look at all of the Bohr models in group 1 and tell me, what do all the group 1 Bohr models have in common? Have a chat with your partner about that. What do all the Bohr models have in common?
One cooking bar. Yeah. This one, circles. That's too big. Like, all of them. Yeah.
What do all of the group 1 atoms have in common? Yes? They have 1 electron on the outer ring. How do we say that? They all have 1 what type of electron? What's that word? Valence.
Lonely electron.
1 lonely little electron. Okay, so all the Bohr models in group 1 have 1 valence electron, 1 electron on the outer shell. Take a look at group 2. What does group 2 have on its outer shell? Oh, it's got 2. So this one has 2 valence electrons. We have chopped out part of the periodic table. What part of the periodic table have we chopped out? Tell your partner, what part of the periodic table have we chopped out? Zoe-san, I think you got it. The transition metals, yes. Okay, we've chopped out the transition metals. Shh. What do we call all the elements that we are left with? Those are our main group elements, okay? Just to remind you of that. Now, that means that groups 3 through 12 are missing. So now we have group 13. How many valence electrons in group 13? And for valence electrons, I'm just going to start putting VE, okay? 3 valence electrons. How about group 14? 4 valence electrons. Now, I want you guys to notice, in terms of remembering this, in terms of making it easy to remember, group 1 has 1 valence electron. Group 2 has 2 valence electrons. Group 13, if you ignore that 1, what do you have? You've got a 3. They have 3 valence electrons. Group 14 has 4 valence electrons. Group 15 has 5 valence electrons. 16 has 6 valence electrons. 17 has 7 valence electrons. Now what about group 8? Group 18? Yes? 8 except for helium. What we can say about them is that they all have full outer shells. How many electrons does it take to fill the first shell? 2. How many elements are in period 1? How many elements are in period 1, Ryan? 2, absolutely. Okay? And how many electrons does it take to fill shell number 1? 2. How many electrons does it take to fill shell number 2? 8. How many elements in row number 2? 8. How many electrons to fill shell number 3? 8. How many elements in row number 3? 8. Because as you go across the periodic table, you'll notice that in period 1, we just have 1 shell. In period 2, how many shells do we have? We have 2 shells. In period 3, how many shells do we have? Period 3, we have 3 shells. So basically what we are doing as we go from left to right across the periodic table, we are filling a shell. And period 4, even though we only have 2 elements there before the Bohr model kind of breaks apart, it will have 4 shells. So for group 1, how will group 1 become ions? Will they lose electrons or gain electrons? Group 1. Am I going to lose electrons or am I going to gain electrons in group 1? In group 1, I am going to lose. So let's show these electrons being lost. We can't erase them because they're printed on the page, so let's cross them out. So elements in group 1 lose how many electrons? In group 1?
Sorry,
1 electron. And if you lose 1 electron, that's like taking away a -1. What do you end up with? +1. And so we have it forms ions with a +1 charge. So everybody in group 1, when it forms an ion, it will form an ion with a +1 charge. Group 1, +1. Group 2. How many electrons in the outer shell? 2. So is it going to gain or lose electrons? It's going to lose. How many? It's going to lose 2 electrons. So let's cross them out. Bye-bye. Bye-bye. Adios. See you later. Hasta la vista. And auf Wiedersehen. There we go. Cool. All right. And so they tend to lose 2 electrons. And what charge do they form? If you lose -2, you become +2. Elements in group 13. Remember, group 13, how many valence electrons? 3. Okay, 3 valence electrons. So will they want to lose or gain? They will want to lose 3 electrons. 1, 2, 3. 1, 2, 3. They're going to lose 3. And if we lose -3, what do we get? +3. So if I were to say to you, what is the charge of a calcium ion? You actually would not have to draw the entire Bohr model. You could look at calcium, say calcium is in group 2. It has 2 valence electrons, so I need to take those away. That means calcium is going to be +2. Okay? You can draw out the whole Bohr model if you find that helpful, but you don't have to. You can do those little shortcuts. You can say, hey, what if I were over in group, let's just do group 17 for a moment. How many valence electrons in group 17? 7. Okay, we got 17, so there's 7 valence electrons. Is that almost full? Is that closer to full or closer to empty? Closer to full. So how many electrons does it need to gain? 1 more. So we're adding a negative. So what is the charge of everything in group 17 going to be? We have added 1 negative, so that's going to be -1. So everybody in group 17, you can see we've got a gap. We're going to fill in that gap. Okay? Everybody's got a gap. We're going to fill in the gap. So everybody in group 17 gains 1 electron to form ions with we've added -1, and so that's just going to be a charge of -1. Group 16, how many electrons in the outer shell? Group 16. 6. 16 has 6 electrons. Does it want to gain or lose electrons? Gain. How many? 2. So we are gaining 2 negatively charged particles. So we're adding -2. What is the overall charge? -2. So it gains 2 electrons. All of these patterns can actually make drawing Bohr models easier for you, because you can say to yourself, I know that oxygen, for example, is in row 2. So it has 2 shells. Bam, bam. Yeah? I know that it's in group 16, so it has 6 electrons on its outer shell. So I can draw 1, 2, 3, 4, 5, 6 on the outer shell. So if you want to use those kind of tricks to kind of help you do it a little faster, you can do that. Okay? In the meantime, in group 16, we should draw in our extra electrons. Okay, let's draw in our extra electrons there. Group 15, 1, 5. How many valence electrons? 15 has 5. How many electrons does it need to lose or gain? 5 needs to. You could either lose 5 or you could gain 3. Which is easier? Gain 3. So it's not going to lose 5, it's going to gain 3. If you're closer to full, you're going to gain. If you're closer to empty, you're going to lose. So 3 or less, you'll lose. 5 or more, you will gain. Okay, so this guy, we're going to add 1, 2, 3. Phosphorus, 1, 2, 3. And so elements in group 15 gain 3 electrons to form ions with a what kind of charge? Negative charge, negative 3. Okay. Now we already know elements in group 18, their valence shell. What is a valence shell? Valence means outer. Their outer shell is full, so they don't need to gain or lose electrons to become stable. Remember, it's that full configuration that is stable. So they don't form ions. But I always get asked about group 14, because group 14, 4, you would either have to lose 4 or you would have to gain 4. And neither of those actually tend to happen. They don't tend to form ions. Instead, they will share their electrons in order to get a full, stable shell. So I'm going to show you a little something. You don't need to know this yet, but just so you know what I'm talking about. Carbon, in its outer shell, has 4 valence electrons. 1, 2, 3, 4. Are we okay if I do not draw the inner shell? Is that okay? This is just the outer shell. Hydrogen has 1 electron. Yes? Well, if I have 4 hydrogens, oh, by the way, how many electrons does hydrogen want to be full? Each single hydrogen wants, it's got 1, so it wants a second one, so it wants 2. So what's going to happen is rather than this guy giving electrons to that guy, what's going to happen is carbon is going to say, here, hydrogen, share my electrons. And hydrogen is going to say, okay, and in return, I will also share my electron with you. That's how one type of compound is made. That's how covalent compounds are made. Okay, so that would be a compound called CH4 because it has 1 carbon and 4 hydrogens. You do not need to be able to draw that, but if you're like, why is carbon not gaining or losing electrons? It's because it tends to share electrons instead. Pardon me? It does not have to be hydrogen. You can actually end up, it does it with any of the nonmetals. When they act with other nonmetals, they will always share. Okay, so if you have a metal and a nonmetal, metals are electron givers, nonmetals are electron takers. So what you'll do is you'll have transfer from the metal to the nonmetal. You'll end up with a positive and a negative, and those two will actually stick together because positive attracts negative. These guys here, any nonmetal and nonmetal, they're both electron takers. They both pull on electrons really well. So they'll just end up sharing with one another. Okay? And we'll do that a little bit more in Unit 3. All right? So that takes care of this sort of patterns in periodic table. This little chart here, worthwhile visiting again and again, just to kind of check and see how you understand it, how you feel about it. I would like bookmark this page if anyone wants to put a sticky note on their page. I've got sticky notes here. It's a good page. Page 105, good page to study. Okay, see you guys later. Okay. And with that being said, are you guys familiar now with isotope notation? Do you remember that? Isotope notation? Anyone remember another word for isotope notation? This is on page 106. You may also hear the yes. Sorry? Nuclear notation, yes. Both of those are ways that we can refer to this. And if you remember, where does the big number go and where does the small number go? The big number goes on top and the smaller number goes on the bottom. So the bigger number is protons plus neutrons, and that goes on the top. The big number goes on the top. The smaller number is just the protons. That's our atomic number, and the small number goes on the bottom. Okay, so mass number on the top, atomic number on the bottom, and because we've now been doing stuff with ions, we have a third place to write something, and that is our net charge. Okay, so that's the charge of the ion. So if you remember, hey, what group would you find magnesium in if it has a charge of +2? What group is magnesium in? Without looking at your periodic table.
No, not water, right? No, sorry. Yeah. Wait, gain 2.
Did this guy gain 2 electrons or lose 2 electrons?
It lost 2 electrons.
It lost 2 electrons. What group has 2 electrons in its outer shell? Group 2. Okay, so I could give you a symbol like this that's not labeled, and you would have to say from this symbol here, how many protons do we have? We have 12 protons. How many neutrons do we have? We have 13. You're going to take the big number and you're going to subtract the small number. That's going to be your mass number minus the protons, and that's going to give you 25 minus 12 is 13. Now, electrons. How many electrons do we start with? How many electrons does neutral magnesium have? Yeah, it'll have 12 electrons, the same as the number of protons.
But then you took away 2 of them.
We lost 2 electrons. So that's going to be 12 minus 2 is 10 electrons. So we have 12 protons, 13 neutrons, and 10 electrons. What number is on the top? What is this 48? That 48 on the top is the mass number. Tell your partner, what does the mass number equal? Mass number equals the protons plus neutrons. All right. How about the 22? What does the 22 stand for? Protons. And what do we call that number? That is the atomic number, yes. Now, there's nothing up in this little corner up here. You look and you're like, oh, nothing. What would go up there? Charge. Okay, so we're going to write charge. And in this case, it's equal to 0. Using that information, tell your partner how many protons, how many neutrons, and how many electrons we have. And you know what I'm going to do? Because you are allowed to go ask anyone you want to. So once you have figured it out, I want you to ask your partner, see if you got the same result. If neither you nor your partner know, then I want you to go find someone who does know the protons, neutrons, and electrons. Because I'm going to call somebody's name at random. Okay? Now, if you really don't know and you're not, even if you're just not comfortable talking to me, you can just say pass. Okay? So if you're like, I don't want to talk to you today, Ms. Spence, that's okay. You can just say pass.
48 minus 22, 46.
Anyone need any more time? Raise your hand if you do. No one needs more time? Raise your hand if you need more time. Nobody? Okay. Oh, that's no fun. She's not here. No. Hudson. How many protons do we have? Pass. Okay. You know what I'm going to do? We're gonna not pass for a moment because I'm going to I'll highlight it in green. This number here, the number at the bottom, is the atomic number, which is equal to the number of protons. How many protons? 22. Beautiful. Okay. You can still, even if I ask you a second time, you can still say pass. You can be like, screw off, Ms. Spence, go on, talk to somebody else. Okay, that's all right. All right, next, we would like the number of neutrons, Malia. 26, and how did you get that? Yeah, this was 48 minus 22. So to find the neutrons, what you're going to do is you can even just treat this like a little subtraction problem where you have one number written over the second number. And if you subtract, this is our mass, and we subtract the protons, we get 26 neutrons. So that's our mass minus protons. And you can just do that subtraction right on the symbol itself, right on that isotope notation. Electrons. Jennifer, how many electrons? 22. And how did you know that? And if you're like, I don't know, that's okay. That's fine. Okay. She's not here. Max, how would we know that we have 22 electrons? Yeah, the charge is 0. And therefore, the electrons, which are negative, is equal to the protons, which are positive. Very nice. Okay. Let's try the next page. Oh my gosh. This is backwards this time. Goodness me. Okay. So you guys are going to try and fill these things in to the best of your ability. Try to fill in the boxes. I would advise starting with the fact that protons are equal to 15. Start there. And the number 15 is going to go somewhere. Figure out where that goes.
Okay, thank you. So the thing is phosphorus. Yeah, what? Figuring that out. Okay, and then it's negative something. It's negative. Is it? Because it gains more electrons. If it has 18 electrons, is that stable? No, like, yeah, it has 18 electrons. But like, it's stable, but normally it has the same amount as the proton. Yeah. Oh. Because that's an ion.
Make sure you check with your partner as you're working through. If neither you nor your partner know how to do it, go find somebody who does. Feel free to get up and walk around if you need to. Who needs more time? Anyone need more time?
Yes.
No one needs more time? Okay. Well, he's not here. All right. Sophia, where does the number 15 go? Yeah, it goes right down here. That is our atomic number, the protons. It goes at the bottom. What element is that? What symbol are we going to have in this big box here? Zoe, what? Who is it? P. We're going to have P for phosphorus. Because if we look on our periodic table, atomic number 15 is phosphorus. All right, mass number. So what's going to go up here? Our mass number. Valerie. Sorry? 32. How did you get 32? Protons plus neutrons. So that is our protons plus our neutrons is 15 plus 17. And that's going to give us our mass number, and that equals 32. So that's where we got that 32 from. All right. And our net charge, Matthew. 3 minus. How did you get that? Yeah, we have the electrons minus the number of protons. So we have 18 minus 15 is 3. And that means we have 3. This is our electrons. Those are our protons. We have 3 more electrons than protons, which means it's going to be 3 negatives. So 3 negative. Very nice. All right, we're going to try the next one. Boys? Okay. How many protons do we have? Oh, he's not here. Mateo. 18. And that is our atomic number. I don't know why I didn't ask what the atomic number was. I'm just silly, that's all. Okay, what element do we have, Spencer? Argon. Okay, so we have argon. Okay, because we go to our data pages and we say number 18 is argon. Excellent. All right. Ryan, what is our mass number? 40. How did you get that? You just guessed. Okay. I'm going to ask Sue, how would we get 40 for the mass number? We would need to add the protons plus the neutrons. 18 plus 22. Protons plus neutrons. I'm thinking you did more than guess. I'm thinking you like kind of intuited that. Am I correct? I don't know. Okay. That's all right. So we got 40. Okay, that's great. And, oh, she's not here. Zoe-san, what is our net charge? 0. Why is that? Because the protons and the electrons are equal. Okay, so what that means is that, and what type of element, what group does argon belong to? Cody, what group does argon belong to? It is a noble gas. What do we know about the noble gas's outer shell? What do we know about the noble gas's outer shell? Yes. Yeah. Yeah, it has a full outer shell. So does it surprise you that the net charge is 0? No, it shouldn't, because it doesn't want to gain electrons. It doesn't want to lose electrons. Okay? All right, and that takes us through the end of this. Now, on the next page, if you're like, I need more help finding protons, neutrons, and electrons, and writing the isotope notation, there are a bunch of videos here with practice problems. And you are welcome to, if you wish, watch those videos. But if you don't need to, you guys have already done pages 109 and 110. We are going to carry on with 111, 112, 113, 111 to 113. And I'm going to throw in 114, actually. And 114. There we go. And I'll get rid of this because this was last day. I would like to have a quiz on Thursday on Bohr models and isotope notation. Or I can break it in half. We can do Bohr models on Thursday and isotope notation on Friday. Break it in half? Okay. Bohr model quiz Thursday. Yeah, but it's like the morning of Halloween, like who cares? Pardon me? It's the afternoon of Halloween, but who cares? Maybe when you finish your quiz, I'll give you a candy. How does that sound? On Friday? Okay. That means I have to go buy candy. I don't normally, because I live on this weird little street that's like off of the main street. There's only 4 houses on it, and it doesn't really have street lights. So nobody, like, I once have had like 1 trick-or-treater, so I normally don't buy candy, but I'll buy candy for you guys. Okay, so Bohr model quiz Thursday. And then we'll have our isotope notation quiz.
Are we gonna have any pre-test?
Friday. Yes, you will have re-quizzes.
No, pre.
Oh, pre-quizzes.
Like show us what's on it.
Do you know what? Honestly, no, but it will look a lot like the worksheets that are in your book.
Okay.
Do you know what I mean? Yeah, it's not going to be like one of those things where you're like, oh, what does it look like? It'll be like, please draw me a Bohr model of, a nitrogen ion. right? It'll be like that, okay? So really what you're doing on pages 111 through 114, that's kind of like quiz stuff, yeah? And if you finish this and you want to work ahead, feel free to go ahead to page 115, yeah? Don't be shy. This is awesome.
Yeah, the last one.
Okay.
It just means that oh, that sounds good. But it depends on like studio mode. If I do this, yeah, I add more. But if
So those are like red lemon grape sauce.
oh my god, bro, he was in my BCA. Just don't eat any food in front of him because he will come after you for it. No, like, oh my god. Whenever someone had food, it'll just be like, we're like begging for him. Please feed me. Yeah, it was so annoying. He's nice. He's still fine. That's true. Already kind of compared to some people. I'm literally living in the shadow because he's taller than me. Like literally. And yeah, I am literally like living in the shadow now. Oh my god. No, I didn't listen to it. I didn't listen to it. My did not. Actually, so bad. I genuinely did not like it. It's just so bad. If I said that, I would like drop it. Yeah, that's true. That's true. Exactly. It's like, girl, why you like you made literally 200 songs with stupid ex. Like, I like songs that actually. You know, I like songs about important things, like how your life is like that. I did like 111 likes.
Okay. So now you can do 112.
That's
Yes.
yo, my mom threw away my pen. Because my little brother spilled it. She was very not happy about it. was so good. It's just not.
And next year,
It's so bad. Yeah, it was so bad. I think it's so bad. I just want to remind you. No, like I don't know. Like how it is. Like I like I don't know if this completely counts as a love song, but it's like yeah, I like that one. That's good, like sad. It's like a sad. Yo, I sang that as my choir. I did get it, and I had 20 voice cracks. Yo, I have this problem.
Right.
But like for that one, they only made you do an audition for like just to check your voice range. Like you don't need to get actually like I genuinely had this problem where if I had such bad way bad if I sang and I just someone else was recording, I had the own feeling it was so bad. It was so painful. I like embarrassed myself in front of my family. I used to have I still have it's a lot easier to get over stage fright and you have to do the dumbest things with your fire. Like, you have to do a lot of dumb things. It's a great way. Sounds like a good idea, right? Yeah, perfect. Do that like my clothes. Yeah, that's you. I have my aunt did that for one of my shirts. But it was really cute. I was like, I was sitting at my desk, like watching. You know, I wish I could do that, but my mom would not let me have it. I mean, it was like on Saturday, so yo, especially on Saturday. Yeah.
So that one is very, very.
Yo, every weekend, I was like, oh, you're the dishwasher tank. Yeah, that happens. My mom was like a whole street completely. It's not every time. But I usually just do the dishwasher. Here's the apple.
Okay.
Never left the dish. Yo, and the one problem because my brother is really bad at swimming. Okay, like he sucks. You know, like how the big flat plates he puts it on the top. Like I don't know, it's so bad at it. Like I put my plastic on the ground and then like plate. Yeah. Yeah. And then like plastic plate. Like the big one. Anyway, it was really. I was like, how did he? Like, why was it anyway.
Miss?
I'm sure her face. Isn't she beautiful? Yes. It's like a close up. Yeah, it's a close up of her. It's like, it feels wrong. Yeah, it's a little long. Yeah. When you zoom in, you realize how many mistakes there are. Oh my god. And that means that like after 5 days, he's like, and 25 only, I have this one friend who like makes a good one makes like 3 units. It's scary. I'm like, where do you get this? Yeah. That's fair. No, she'll like make a new one, you give them a job, a weapon, and it's kind of it. And then sometimes, but then she has these like 10 15 LCs that are really, really good. Yeah, kind of simple. I'll pick out summer and she's like the same as actually most of my LCs right now. Like most of the LCs that I use from here right now from that same that's so yeah. I'm looking for 2 weeks to use my bucket to this I have to do with bucket soup, and then I touch it up with a different isotope. I have this one selection. So this is the thing that we can have, and it's it like lassos the edges, and then I can set. It was so good. But I can't use it in simple. Here's the thing, I can animate, but I've never finished an animation or even come halfway. That's it. I do not have I do not have a patience for it. Like maybe I'll finish. I have so many ideas for adding and things like that. I'm like, yeah, just put them in my head, and then I never. I'll block them out on paper. Block them out on paper. Well, you want to start with like the idea, and then I like if you something like dialogue. Sometimes it also depends on people. Either write down yeah, that's super me. You can go like everything simple and one that's focus. But like something so hard. Especially when it's then it's like staring at my and then like you're probably just be oh my like I've decided, I've just decided I'm just not gonna be nice. And if I ever do, I'm gonna get my certificate. But what I like to animate is hair. Everything else kind of I can also lip sync very well. I have actually I'm freaking animate, and then I can like make sure not like I can like animate it. So if I can animate, I can animate like my that would be really fire, but I wouldn't do like edit to like my I'll just kind of like clean or something. Apparently that's it's easier, but like I know. That studio has screening in it and also frame by frame. I can't remember if Krita. I think Krita has probably does. Yeah, it does. What are you doing on it? I really hate instructions. Like, not watching the instructions. Why watch the instructions? I did not watch the instructions. You know what I did? You know what I did? If I'm like looking for a tool, I can whatever. I'm kind of using like my shortcuts, like Yo, I never know. I only like the only shortcut I know here is the outliner. No review. I'm never ever again. Too bad. I'm like the main opera. Yeah, that's true.
Are you guys all finished? Did I not give you enough?
No, you didn't. No.
I finished up to 150.
No.
Yes. There we go. Some of them only have like
Who is this bro? He's like kind of weird, but he's serious, like a fantasy. I thought he was going to. Okay, we have genuinely think that genuinely feels like